Hey, welcome. Thanks for attending my talk. Fast track your path to senior C sharp developer. Um, I'm Andrew Stellman, and I've been a team lead, a team member, and a manager, and also an O'Reilly author and trainer. Really happy to be at this conference sponsored by O'Reilly. And over the years, I've worked with developers at every stage of their careers. From people writing their first lines of code to senior engineers leading teams. And one of the first things I learned along the way is that advancing your career as a developer isn't just about time or titles. It's about how you approach your work. As developers, so much of how we viewed and how we're viewed and appreciated by others, like whether by the peers or team leads or managers, really comes down to to the code we write and how we solve problems and the habits we build around those things. And so this talk is about specific technical habits that will make your work stand out, habits that senior developers respect and notice. We'll focus on things you can start doing today, practical steps that don't require years of experience, just a willingness to think a little differently about your code, because writing better code isn't just about being a better programmer. It's about building a reputation that helps you fast track your career. So like I said before, I wear a few hats. I'm a team lead, I'm a team member, and a manager in one life, and an O'Reilly author and trainer in the other. And the common thread between them and what I'm most passionate about is helping people learn new things and advance their careers. And let me start with a story that sits right at that intersection. A couple of years ago, a developer on a team I just joined asked me something interesting. He said, people immediately treat you as a senior developer, and they don't treat me that way. And how do I get there? And that stuck with me. There's a lot of advice out there about career growth, building your brand, networking, how to dress, how to talk. But I knew that wasn't what he was asking. I'm a technical person, and in our world, our work speaks for us. So honestly, developers will tolerate just about anything if they respect your work. And we're pretty harsh in our judgment if we don't. We're kind of known for that. And so that's the question I want to answer today. What are the specific, achievable things, techniques that you can learn, habits that you can build that will make your work stand out? What are some simple things that you can do to help earn the respect of senior developers around you and fast track your path to becoming one? Let's face it, nobody wants to work with confusing code. Not you, not your teammates, definitely not your future self when you revisit that code 6 months later. And that's why readability isn't just basic, it's essential. Readable code doesn't just make everything you do faster and easier, it actually sets you apart. And that's why it's one of the first habits senior developers look for, because it shows you're serious about your craft. Have you ever looked at your own code and thought, what was I even doing here? We've all been there. Readable code solves that problem. It keeps you in the flow, and it makes debugging less painful, and it helps you produce better results. And here's the kicker. When senior developers see your clean, readable code, they'll notice. Readability says, I've got this. And that's exactly the kind of thing that helps you stand out and fast track your growth. Because growing your career isn't just about technical skill. It's about how other people, and especially senior people, team leads and managers see you. So what we're going to do right now in this section is we're going to dive into what makes code readable step by step. And here's a spoiler. Even small changes can have a huge impact. And the best part, these habits we're going to talk about aren't just about making your life easier today. They're about laying a foundation for your best path to becoming a senior developer. And by the time we're done, you're going to see how these principles go beyond code and straight into building your career. So let's start with something I think we've all experienced. You open a file, you look at some code and you think, what idiot wrote this crap? And then it hits you, it was you. And suddenly you're trying to reverse engineer your own brain from like weeks or months ago. And that's the problem with unclear code. It leaves no breadcrumbs. Readable code, on the other hand, is kind of like writing a helpful note to your future self. It saves you time and a whole lot of frustration. When you're just starting out, it's easy to think that senior engineers know everything about the code they write, that we can keep every detail in our heads, like we're some kind of magic. Like it can feel like we're kind of on another level entirely. And here's the secret: very few people actually do that. As developers, almost none of us keep all the context of our code, all of it, in our heads for so very long. Once we move on to our next task, those details, they're kind of gone. And senior developers just have seen so much code that we recognize a lot of patterns. I've been looking at code for more than a quarter century, more like 35 years. And it makes it easier for us to understand new code we haven't seen before. But here's another big secret. We're also good at writing code that's easier to read. And that way, we don't have to work so hard to understand it later. The more you write readable code, the better you get at reading any code, even code that's a little difficult to follow. It's like a muscle you build up over time. Readable code isn't just about saving time down the road. It helps you right now. When your code is clear, you can jump back into it and keep your momentum. And that's how you stay in flow. Flow is that magic state where everything just clicks. And if you've experienced it, you know what I'm talking about. Readable code helps you stay focused instead of breaking your stride to untangle confusing logic. Now, here's something I like to call the 4 p.m. frustration avoidance rule. Imagine it's late in the day, you're running low on energy, and you're debating whether to grab another coffee. If your code is readable and you're about to start another thing, no problem. You dive in and knock it out. But if that code's a mess, you'll burn the first 30 minutes just trying to figure it out. And then it's like almost 5, and you're just getting started. You've wasted time and energy you wish you'd had back, and your brain is already starting to hurt. And you kind of wish you'd just put this off to the next day. We've all been there. This isn't just about you either. If your code's hard to follow, your teammates will struggle with it too. It slows everyone down. It makes collaboration harder than it needs to be. Readable code just doesn't have to be rocket science. It's about small, simple habits, using meaningful names, structuring things logically, adding comments where they help. And the best part is you don't have to wait to see the results. The benefits of readable code often show up immediately, sometimes like the same day, the hour you write it. So let's dive in some code. Okay, so this example comes straight from chapter 3 of my book, Head for C#. Just pushed out the 5th edition a few months ago, and really, really happy with how it came out. I think we've had a giveaway at the conference. A few lucky folks have gotten a copy. And in this part of it, we're just starting to teach readability early in the learning process. It's chapter 3. These are new learners, people who are just learning C#. Why are we teaching it this early? Because readability isn't just a nice to have, it's a must have. It's one of those habits that lays the foundation for everything else we teach in our book and everything else I show my teams and everything we do as a developer. Now, as I'm talking about it, some of you might be thinking, this feels pretty basic. And you know what? That's the point. These ideas aren't revolutionary. The real challenge is making a habit of consistently taking the time to make your code readable. And that habit is what sets you apart. Now, we're looking at a chunk of code that works. It gets the job done. But even though it's just a few lines long, it's practically unreadable, right? You'd have to wrestle with it just to figure out what it's doing. And this is a great starting point to show how readability makes a difference. What we're going to do is break this code down step by step and show how even small, deliberate changes can transform it into something much cleaner and easier to work with. So let's look at some of the problems with this code. We'll start with the cryptic variable names, T, M, and TB. What are they? What do those do? I mean, who knows? They don't give us any clues. So we're left guessing. And then there's unclear message names like klstrv and chktump. They're vague and they're cryptic, and they force you to dig deeper into what they do just to figure things out if you're trying to work on them. And finally, we've got these magic numbers, values like 160 or 2, sprinkled into the code with no explanation. Why are they there? What do they mean? It's anyone's guess. And when you run into unclear code like this, whether it's from someone else or your past self, it's frustrating. You waste time and energy just trying to figure out what the code is supposed to do before you can even start working on it. Readable code eliminates that friction. And you know what? We're talking about fast tracking your path to senior C# developer. Senior developers who look at your code, if they can read it immediately, they might not notice, but if they can't, they definitely do. Readable code just eliminates all that friction. It's like a fast path through your workday. It saves you time because it's immediately clear what the code does and why it's there. Now, I know a developer who's adamant that all code should be self-documenting and that comments are unnecessary. Now, I don't fully agree with that perspective, but when it comes to code like this, he's got a point. Comments alone will not fix this readability issues. They're just a Band-Aid. And we're going to see why in the next few slides, where we start fixing these problems at their root instead of patching them over with comments. So this code is a great example of how messiness can turn even simple functionality into a nightmare to work with. But the good news is it's completely fixable. By taking small, deliberate steps, we can turn this messy code into something that communicates its purpose clearly, and that's exactly what we're going to do next. Okay, so this builds on what we've talked about. Confusing code is tough to work with. Not because it doesn't work, but because it's hard to understand. Improving readability starts by pausing to figure out what the code is supposed to do. And in Head First C# in the book, this example mirrors the real-world challenge of inheriting or working with unclear code, which again, I really wanted new C# learners to learn about from the very beginning because it's such a common experience for all of us. And I wanted us to, part of my job is preparing people to be professional developers. I spent 20 years more just learning how to write books to help people do that. And that's why we're teaching these things early. And this is why it's a really important path on your step on your path to becoming more senior, because it's all about learning how to decode things and then uncovering the intent behind your mess. Now, before I even started working on the readability of this code, I took a step back to figure out what it's actually supposed to do. And in this case, it's part of a cooling system for a factory that makes candy bars. And I kind of chose that example because there's just no possible way, unless you just happen to work in that industry, that you could have figured out from the obscure names and out of context numbers. And that's one of the most important parts of making code readable, is understanding its purpose. Code isn't generic. It always exists to solve a specific problem or perform a specific task. If you don't start with the purpose of the code and you're just guessing at what needs to change, understanding what the code is supposed to do gives a foundation to make meaningful improvements to it. Now, here's a step that's easier to overlook. Don't just rush to rewrite the code. Take a step back, think through what each part of the code is doing, and try to see the bigger picture. Sometimes The most important thing you can do for readability is to just sit with a code and figure out its intent, figure out what it was meant to do, because that's the foundation for making real improvements. Now here, we've added comments to explain what we already know about the code. These comments break down the cryptic variable names, the vague methods, and those mysterious magic numbers. And this step helps us start making sense of the code. But it's just a tool to get closer to clarity. Comments like these are part of the process, but they're not the end goal. Remember that developer I mentioned who hates comments? You know what? When you look at these comments here, he's got a point. These comments add extra text, but they don't actually fix the underlying readability issues. And anyone reading this still has to process both the code and now those extra comments. And we've actually added extra work. We've actually added comments and made the code harder to read because you got to get through more stuff to understand it. So comments are useful, but they're not a substitute for readable code. So where do they come in? We'll talk about that in a minute. Right now, our goal isn't to rely on comments to explain unclear code. It's to make the code clear enough so that it doesn't need them. Adding those comments was about laying the groundwork for code that speaks for itself. Once we've decoded the intent, what the code is meant to do, we can start improving the code so it communicates its purpose clearly. No need for extensive comments. And so now we have a roadmap. We use comments as a tool to decode intent and then focus on making the code readable by itself. And next, we'll dive into how better names and structure can make the code's purpose crystal clear, which saves time and frustration for everyone. Okay, so now that we've decoded the intent of the code, the next step is to make it speak for itself. Make it so clear and so self-explanatory that we don't need comments to explain it. Reusable code isn't just about avoiding confusion. It's about creating something that others and your future self can immediately understand and work with. And this is where good names, structure, and clarity come into play. Sometimes developers, and honestly, often senior developers, which is why this is sometimes you don't want to necessarily mimic or emulate absolutely everything the senior folks around you do. Sometimes we feel that there's kind of like this unspoken rule that names have to be short. Like, variable names or methods or classes or constants can't have whole words. And like we want to make them as short and compact and difficult to read as possible for some reason. And you know what? That's freaking nonsense. IDEs like Visual Studio or Visual Studio Code make it really, really easy to change names, or Writer, make it super easy to change names. And it's always better to have a name that you can easily understand, even if it's long. And, maybe once upon a time, it took a few extra milliseconds longer to type longer names. But now every IDE has autocomplete, and AI tools make it even faster. There's no cost to longer names, but there's a huge benefit in clarity. Now, in the original code, if you remember, the temperature check was buried in a mess of logic. We pulled it here into its own method, is nougat too hot? And you can see there's actually two versions of it. And so first of all, the name makes it obvious that this method checks whether the nougat's temperature is above a safe threshold. And next, we tackled the names. The variable t became temp. So we knew it as a temperature. And while temp is shorter for temperature, everybody looks at temp and knows what that means. And we also replaced that magic number 160 with this constant max safe temp, which again, it makes it clear that this number represents a temperature limit. Constants like this add context, making the code more readable and maintainable. And refactoring cool tools in Visual Studio or Writer have built-in ways to extract, replace constants we replace magic numbers with constants. Readability is all about making choices, and any one piece of code can be written in an almost infinite number of ways. When you write code, you're constantly making choices about how to balance clarity, brevity, and functionality. And the goal is to make choices that help others and your future self understand what the code is doing as quickly as possible. Now, this slide shows two versions of the same method, like a more verbose if-else version and a more concise Lambda version. Now, some developers prefer the if-else because it's easier to, they think it's easier to read because it's longer and simpler. Now, others think the Lambda is easier to read because it's more compact and quicker to process. And you know what? There's no universal answer. There's no single right answer. You have to figure out what's best for your team and your code base. And some of that is experience. Some of that is honestly talking to people. Ask people in a code review or in a pull request, which one is better? Remember, and this is like a really, really important thing to remember, you only write code once, but that code gets read many, many times. So it's worth your time taking a little extra time to make it as clear as possible, because you're doing that just once. And then all those many, many times it's read in the future, you've saved time and mental effort later. You know the people on your team. You have a choice about what you think will be more readable for them. And because this is all about making choices that make your code easier for other people to read. This example shows you that C# is a really flexible language. And in any programming language, there's a lot of ways to write any one bit of functionality, and it's especially true of C#. Your job in readability is choosing the way that you think best communicates the intent of the code. And that's why we spent so much time thinking about the intent. And this is where readability becomes a habit. Thoughtful choices like better names, meaningful context, clear structures, create code that's easier to work with, not just for you, but for everyone. Because in the end, making code readable isn't just a favor for your future self or your teammates. It's an investment that makes every future interaction with that code smoother, more efficient, and just generally easier all around. Now, I want to talk about a simple, repeatable technique that can turn confusing, messy code into something readable and maintainable. It's straightforward, and once you get the hang of it, you'll wonder how you ever coded without it. And this builds on the readability improvements we've ever made. And this is one of these things, these practical things that you can start doing today that will help you on your path. We're going to show how to take inline logic that's hard to follow and transform it into clean, structured code that makes its purpose a lot clearer. So here's that before code. Now, what you can see if you look closely is it already has some improvements from the earlier slides, like better class and method names. And it uses that is nougat too hot method we just created to check the nougat's temperature. But this block of code is still trying to do too much all at once, which makes it harder to read, understand, and work with for your teammates. So to make this code more readable, we used Visual Studio's extract method quick action tool. And with just a few clicks, you can see we selected it, and then we chose selected it, and we chose extract method. And then with a few clicks, you can extract it. And what we did was gave it a meaningful name, do CICS vent procedure. Now, you might not know what a CICS vent procedure is because it's specific to this particular candy manufacturer. And that's an important lesson. Always think about what the people who will read the code already know from the real world and use that knowledge to choose names that will make sense to them. And it will immediately tell them what that method or variable or class or whatever does. And when you do that, it saves everyone reading it from having to figure that out on their own. And look at this after code here. The if statement we originally looked at is now much clearer, cleaner. you can immediately see that it checks if the nougat's too hot and does the CICS vent procedure, and that's it. And the abstracted method, do CICS vent procedure, handles all the details of what needs to happen when the temperature exceeds that safe limit. Now you can actually look at this, and even though that you aren't familiar with the sort of the industrial process that this is from, you can look at it and read through it and actually have an idea of what it's supposed to do. Like just look at that code and you can see that it does kind of get a sense of what it's doing in the real world. And here's a really important piece. We also added XML documentation to the extracted method. You can just start typing / and your IDE will just start filling in the template for it, especially if you've got GitHub Copilot. This is we added the summary tag, and that explains in the top method that the code runs every 3 minutes. Check the system, check the temperature, and in the bottom method, we performed the CICS vent. What matters is we're explaining it in really simple terms in the right place. And here's the thing. Remember that developer who doesn't like comments? He's much more likely to see the value of this XML doc. Why? Because these comments are exactly where they're supposed to go. And they use the syntax, this XML doc syntax, that lets the IDE and other tools like documentation page generators read them. So they're not just extra text or boilerplate or stuff that's added. They're actually built into the code, and that makes makes other developers a lot happier to see them. And this technique, when something's complex or convoluted, extract a method and add XML doc, it actually solves that tricky question. When's the right time to add comments? A lot of developers struggle with this. They don't want to over-comment, but they also don't want to leave people guessing. With this approach, with this really simple technique, it's straightforward. If your code is hard to read, extract a method, and then add XML.comments and explain it. And now you know exactly when to add comments. You'll have a much better idea of what to say, and your teammates, especially the ones who normally hit comments, will actually appreciate them. And even better, AI tools like GitHub Copilot can help you write those comments, although always read everything that comes out of an AI because they do make mistakes. Okay, so are you thinking this seems obvious? I mean, maybe it is. But even if it is obvious, when's the last time you actually did all this? I bet for all of you, or at least for many of you, you probably seems like the sort of nice to have thing that you'd eventually get to. If this seems really critical, then you're already on your way. If it seems like a nice to have, think about how you can get into the habit of doing this. Because this helps you with readable code, and readable code is an investment in collaboration. Like using techniques like this, you're creating something easier for others to work with. And when you create things that are easier for others to work with, that is a huge step forward on your path to becoming a more senior developer. So now we're going to talk about simplicity, which might sound, well, simple, but it takes effort and a change in how you think about coding. The good news, it's achievable. And actually, it's one of the most valuable habits you can build on your path to becoming a senior developer. I want to share you something from my own experience. In my late 20s, I wrote the most complex code of my life. I'd been managing a team for several years. This was back late 90s, early 2000s. And I had enough knowledge to build big, complex systems, but I hadn't really figured out how to keep things simple, or even that it was something I should be thinking about. And if I could go back in time and give myself one piece of career advice, it would be this: figure out how to make things simple. It's not just about writing less code. It's about writing code that's easier to work with for you and everyone else. Okay, so let me tell you about the Oster Kitchen Center. This is a kitchen of clients that was made from the late 70s through the early 90s. And it could do it all. It was a mixer, a blender, a food processor, all in one unit. And I actually had one. It was a gift I got in the early 90s. I was studying computer science at Carnegie Mellon University. My my junior year of college. I just moved into my first apartment, and it was perfect for a small kitchen because it promised to replace multiple appliances. Here's the problem. When something tries to do everything, it often ends up not doing anything well. The blender was underwhelming. The food processor was clunky. The mixer wasn't nearly as effective as standalone tools, and the whole thing was just impossible to clean. So instead of making life easier, it was actually a frustration. And that's what happens when complexity takes over. It tries to solve too many problems at once and ends up failing at most of them. And this beast of an appliance reminds me of poorly written code. Think about those cryptic variable names like T, B, TM, the magic numbers that were scattered everywhere. It's like using one of these crazy appliances to make a smoothie. It technically works, but way more frustrating and harder than it should be. Here's the wild part. Because I had this thing, I delayed getting a better blender or food processor or mixer for years. Years later, my wife and I were still stuck with a bad solution because I just couldn't, neither of us could really justify replacing it. Honestly, it never even really occurred to us because we already had those appliances. Why do you buy a new food processor when you already have one? When we finally did replace them with actual tools that were built for those jobs, it made a huge difference in our kitchen. In code, complexity has the same effect. When you've committed to a messy system, once you've done that, it's really hard to replace it, and you're stuck dealing with those inefficiencies. There's actually an old saying among developers: there's nothing more permanent than a temporary fix. And complexity has this crazy way of becoming permanent, even if you never meant it to. This is why we spent so much time earlier on readability and why we're talking about simplicity now. Just like readability, just like the things that were the technique I showed you earlier. This is not like a nice to have thing. This is your best defense about building complexity into your system, because readable and simple code, it's like having the right tool for the job. Saves you time, it reduces frustration, and it makes life easier for everyone who works with it. And here's the best part. Senior developers recognize simplicity. They appreciate it. They know that it takes work and practice and experience to write simple code. So if you can develop the habits that can help you keep things simple, they'll see that in your code. And that's a big step towards being seen as a senior developer yourself. And we're going to talk a little bit about kind of some of the habits that you can get into for that. This is Ryan. He's actually from one of my other books, Head First Agile. He started making a change and then ran into a really, really familiar problem. It's called shotgun surgery. Okay, I'm going to start with like an analogy. Imagine you want to change the tires on your car. When you get the first tire off, you discover you can't put the new one on until you repaint the hood. And then when you take the hood off to respray it, you realize you have to install new door locks first. And then as soon as you get the locks out, you realize you need to replace the engine. Like, that obviously won't happen in a car, but the feeling of that happen, you probably recognize that from some of your own struggles with complex code. There's a name for that. It's called shotgun surgery. And when you start fixing one problem of your code, and suddenly you're like fixing these other two things and then three more, like this trapped in a game of whack-a-mole, right? Where every change you make pops up three more problems in a completely random parts of the code. And then when you try to fix one of those, oh no, you got to fix this other thing too. It's your brain hurts. Frustrating, right? In fact, I bet that some of you are getting high blood pressure right now just thinking about the last time you had to deal with this. And you know what? Let's be real. This always happens at the worst time, like that Friday at 4 p.m. when you're squeezing one last quick fix before the weekend. And now instead of relaxing, you're stuck unraveling a mess and you have to decide, do I stay late on a Friday or do I give myself a horrible thing to think about over the weekend? Shotgun surgery happens when your code is too tightly connected, what we call tightly coupled. It's like trying to untangle a giant ball of wires. You pull one cord and three others come along for the ride. Now, the good news, you don't actually need to be a senior developer to fix or at least help prevent this. You just need to start thinking critically about your code and start building better habits. There's one simple trick that I love to talk about. Ask yourself, what does this class do? And if the answer is more than one thing, it's time to split it into smaller pieces. Like, for example, let's say you're working on a role-playing game and you run across a class called Damage Processor, Combat Logger, Player Health Updater. Someone did a good job of choosing a name for that class that describes all the things it does. But just from that name alone, you can guess that the class is probably trying to do way too much. It's trying to calculate damage and then also log combat stats and also updates the player's health. And you see what happened there? Choosing a good name, making your code readable, helped highlight complexity. And now you can see that complexity right in the name. And luckily, there's a fix for this. Break it into 3 smaller classes: Damage Calculator, Combat Logger, and Health Updater. And then make sure each one does that one thing and does it well. This isn't rocket science. It's actually a core principle that we teach. Again, this is one of those things that I teach new C# learners about in Head for C#, and I think everyone can think about it, even new junior developers just joining a team. It's a principle called separation of concerns, and it's actually a core principle in software design. It means breaking your code into smaller, independent parts, each of them responsible for just one thing. And when each piece focuses on a single responsibility, your code becomes easier to read, test, and maintain. Now, why is this so important? Because when parts of your code are independent, you can change one thing without breaking everything else. It's the foundation for writing code that's flexible and resilient, code that works with you instead of against you. And that's why naming helps. When you come up with a better name for your class that does a really good job of describing what that class does, then if it's hard to name, or you come up with a crazy long name that says like 12 things, then your class is probably doing too much. And that's why that name, Damage Processor, Combat Logger, Player Health Updater, sounded bloated. You find yourself coming up with names like that, that's like a big flashing red warning sign that you've got a separate concerns problem. And splitting it into smaller focused classes makes naming easier and makes your code easier to understand. You know, smaller classes are like a clean desk. They make it easier to find what you need and get things done. And if you can break a class into 2 smaller ones without making things confusing, then do it. Small focused classes are easier to test, read, and change. And they're a big part of saving you from that Friday 4 p.m. headache when you just want to make a quick fix and get home. One thing I want to warn you about, we're not going to go too much into it. It's just really important to think about in the back of your head. Because here's a gotcha. When you split up classes, don't just dump all the complexity into the parameters. If your damage calculator needs like a dozen parameters from like a player or a game state class, you're not really solving the problem. You're just moving it. Keep your classes independent. Give them just what they need to do their job and no more. Like packing light for a trip. You see, you'll thank yourself later. Now, here's a just to talk a little bit more about this. Here's an example from the book, from Head for C#. We built a damage calculator, which we'll see later, a little bit more about later, for a role-playing game as an exercise. It's about halfway through the book, where you create classes called sword damage and arrow damage. And you can tell just from their names that each class focuses on one thing, calculating damage for its respective weapon. Easy to name, easy to use, easy to update. If we tried to cram both into one class or started passing around a ton of unrelated state, we'd be a lot more likely to end up with a big tangled mess. And then our brain's hurting from shotgun surgery. Because avoiding constant shotgun surgery isn't complicated. It's simple because it's about simplicity. look at your classes, think about what they do, keep them small and focused, don't pass around a ton of state. That's it. And that's the thing. Good code isn't about being fancy. It's about being clear. A little upfront effort saves you hours of frustration later, and your team will notice when your code just works. So here's a giant mess of code. I'm not going to go into the details of it. It just shows the code structure for managing weapons and calculating damage in a role-playing game. And it's designed to handle different weapon types, materials, damage strategies. And it's also a great example of how complexity can creep into a design. And the reason I put it up here is because all of this is justifiable. Any of it can work. The question you need to ask yourself is, do we need it? Before you add any layer, abstraction, or pattern, think critically. Does this complexity make the code easier or harder to use? Every addition should solve a simple, real-world problem. Now, this is the example that comes directly from Headfirst C#. And I want to introduce you another really simple technique, and it's called the use, use, reuse pattern. And it's really straightforward. Instead of jumping into abstraction too early, like saying, first we need a weapon damage class, and then we'll figure out the things that inherit for it. If you do that first, you don't know exactly what should go into that abstract class, or if it's an interface or base class or whatever. Instead, create the classes at the bottom of the hierarchy first. We created sword damage and then arrow damage. And as an exercise, we refactored them into weapon damage. We pulled out the shared logic between them. We used them once, then we used it twice. And if you find the same thing is used twice, then you pull it out. Use, use, reuse. And this is a really practical way of making sure that every time you add layers, add abstractions, add interfaces or base classes or hierarchy, it's always done for a specific purpose. And this use, use, reuse pattern is another one of those really simple habits that help you build simple code. So let's just get down to these what we've covered so far, because it's actually a lot. Readability, simplicity, and keeping code easy to change. These aren't just techniques. They're habits that help you stand out and grow as a developer. So now let's bring it all together. In the next couple of slides, we're going to sum up the most important points to remember and give you a clear path forward to sort of help build on these things and start moving ahead as on your way to becoming senior. First, keep your code readable. Readable code isn't just about making things easier for yourself. It's about how others perceive you. When your code is clear, clean, and easy to understand, it shows that you're not just writing code for the sake of getting it to work. You're thinking about the future. And senior developers notice this. They see readable code and think, this person knows what they're doing. It signals professionalism and care, and it builds trust with your team. And just remember, you only write that code once, but you and many others will read and modify it many times. So investing that extra time really to make it readable really pays off every single time somebody touches that. Second thing we talked about, use separation of concerns to prevent shotgun surgery. That horrible thing where one small change forces fixes across unrelated parts of the system, which is a nightmare for everywhere, because that's a classic sign of messy, honestly, junior level design. Although I've seen many senior folks who end up with tons of technical debt and end up with that too. So don't worry, this will be with you for the rest of your career. When you apply separation of concerns, you avoid these issues by keeping your code focused and modular. Each class or method does one thing and it does it well, making changes simpler and safer. And this is how senior developers think. They design for maintainability, and that helps make sure the system is easy to adapt without breaking everything. This level of thoughtfulness says this developer knows how to plan ahead and write professional grade code. And finally, practice just-in-time coding and use, reuse. Just-in-time coding, that's what we'd call it when you're making those decisions at the right moment. You wait until you have the most information, and then you make that great decision. And that's what that use, reuse pattern is all about. It fits with that mindset of making sure that you have a real use for those extra layers, those extra abstractions. By waiting until you've used the code in 2 places before abstracting, that really helps you avoid exactly the kind of over-engineering that leads to shotgun surgery. It ensures that your abstractions are based on real needs, not guesses. And senior developers value this kind of restraint and thoughtfulness. When they see code that's simple and solves real problems without unnecessary complexity, they recognize it as the work of someone who understands good design. Now, I want to give you one more bonus tip. Master your build system. I don't know why, but build scripts, Jenkins files, MS build files, GitHub Actions. So many developers, even really senior ones, don't think of it as code. They kind of think of it as like boilerplate that you copy and paste, magic that just works. But it's indispensable. It's how your code gets into production. I don't know why it's so widely avoided, but that gives you an opening as a junior developer looking to make a huge impact on the team. And remember that junior developer who asked me at the very beginning of this talk, I told you about somebody who asked me, how can I get people to treat me as more simple? This is what I told him. I told him, master the build system. I knew the senior people on that team just hated working with it. You can be the person who's the go-to that when you have to make it, I don't know, deploy a container to a dev Kubernetes or OpenShift instance, or get it to run unit tests or, add code coverage or something. If you really deeply understand your build scripts, which doesn't take that much time and not much work, just people are afraid of it for some reason, you become essential on your team. You become the person who knows that magic. And when you know something that other people don't know, even if it's something that's not hard to learn, that just raises you up in their eyes. So master the build system. You will be indispensable. And that's it. Thank you. Thank you so much. I really hope you enjoyed it. I enjoyed talking to you. Follow me on social media or LinkedIn. I'm easy to find. Just search for my name. I think there's only one person with my name out there. I've been building up a following on Blue Sky lately. I'd love to see you there. And check out Head First C# and my other books from O'Reilly. And thank you so much for attending. I've got a little extra time. We blocked out some time for Q&A. I scheduled this for 45 minutes. I'm right at time, but we've got a couple of questions and I wanted to take a little time to answer them. So first of all, and thank you so much for your questions. I very much appreciate it. First of all, what's my opinion on people who say readable code is mostly just familiarity? That's an interesting question. And I feel like I made a pretty good case about why it's more than that. Familiarity is really, really, really important. Remember how we spent all that time talking about understanding the intent of your code? That's what familiarity means. But also it means often when people say that, they mean genuinely understand the whole system, understand where this code is and in context. But sometimes people also say that as a bit of a cop-out, as a bit of an excuse for badly code in need of refactoring, right? Like that code I showed you at the beginning that was really hard to read, even though it was simple with difficult variable names and method names and magic numbers. Familiarity means understanding offhand what that T means temperature. Well, how about not requiring that familiarity and just writing freaking temperature instead? There's no right or wrong answer to that. And it's certainly a really important point. And I would definitely say that when the person says readable code is mostly just familiarity, they're definitely not wrong. But it's also a really good excuse for you, or a hint for you, to think about, what do we want to be familiar with? Do we want to be familiar with the whole system as a whole, and the architecture and the business logic and the processes we're implementing it? Or do we just mean being familiar with the weird quirks and difficulties that honestly could be avoided without that much work? That's a great question. Thank you so much for it. Okay, another question. Did you ever encounter code where names were maybe too long and that they were ruining readability? That's another good question. And honestly, I've probably been guilty of that. I tend to err on the side of longer names. And I'm sure I've annoyed some people with it. But I think that sometimes it is definitely possible. But it's an easy mistake to fix, if it is even a mistake. Like, if you think a name is too long, the first thing to do is just ask your teammates. That's what they're there for. But also just try it. Go into Visual Studio or Writer or VS Code or whatever IDE you're using. Refactor, rename, and make it shorter, and see if that helps. If it helps, keep it. If it doesn't help so much, Control Z and go back to where it was. That's a great question too. Okay, we got time for just a couple more. Someone says, any approaches to make sure that XML doc and method implementations are in sync? Oh, wow, that's a great question. Okay, so the approach is really habit. One habit is, every time you make a change, go back to the XML doc and read it and see if it makes sense. Another habit is, keep your XML doc concise and short. If you notice in the examples I made, there was just one sentence long. You don't need, like, the beauty of putting work into making your code readable is then your XML doc can be short. And where you have stuff in there, it can be less about what the code does and more about why you did it. That's why that remarks sections are really good. Explaining why you did things is also a really good way to assure that the method implementation and the XML docs are in sync, because it keeps everybody in sync on the ideas, the thought process behind the code, so people don't make huge divergences. There's one other tip. Pop open your code in an IDE that's got the Visual Studio, that's got the GitHub Copilot plugin in, and then ask it, say, can you just specifically give it a prompt, like, look through all the code in this file and identify any XML doc that is out of sync with the code. AI is good at some things and bad at some things, but that's actually a problem AI would be pretty good at solving. Okay, another question. What are my favorite tools in the CI/CD process? Oh, that's a good one. You know what? I'm going to tell you my absolute all-time favorite build tool. I spent years doing Scala code, and if you look at my open source repos on GitHub, you'll see a bunch of Scala code in there. Scala, incidentally, is really, really similar to F#. Some little embarrassing thing. I was having a long email discussion with Mads Torgensen, who's the C# lead at Microsoft. And at one point I saw something and saw some new feature. And he said, did you get that from Scala? And he said, I got that from F#. I'm like, oh, of course you did. A little bit embarrassing on my part, but Scala has this really good build tool called SBT. And the reason I love it is because you can just put your files in the right folders, type SBT, and it just builds the code correctly. And it does something that really good build tools do, and something called convention over configuration. Convention over configuration means if you name your files right, you put them in the right folders, you put everything where it is, then the tool just works the way it's intended. And you only have to add configuration to it if you want to deviate from that intended process. That's my favorite tool in the CI/CD process. But I got to say, the improvements that they've made in MS Build in the last couple .NET versions, amazing. The new shorter CS Proj and the upcoming new shorter SLN, and one thing you notice about the new project file format is it relies heavily on convention over configuration, which is why it's becoming, MS Build is already a great tool, but now it's even better. I'm going to take my last question because we're close to time here. What exactly are people avoiding working with build systems? Are the current systems too convoluted or painful to work with? Or are people just uninterested? That one. People are uninterested. I don't know why. I've worked with dozens and dozens of teams over the years and interviewed, as part of my books, interviewed like thousands of developers. And this is almost universal. People hate build scripts. People hate working with them. People hate learning about the build system. They just want it to be magic. And you'll see this pattern on a lot of teams. There's like one person who's like the designated build troll or whatever, you know, but be that person, volunteer, step up for that job. People will love you for it. I don't know why they don't want to know about it, but they do. It's worked for me. And even on teams where I'm like the most senior person, I'll step up and I'll do the build. And you know what happens then is more junior people suddenly become more interested in it. I don't have an explanation for it. It's like one of those life's mysteries. But you know, it is what it is. Okay. We're at time. Thank you so much. My little mascot here, Samosa. We're going to thank you so much for your time. I really appreciate you staying with us. Solution2 conference for having me. JetBrains and my publisher O'Reilly for sponsoring, and Max for setting this all up and getting in touch, and everyone in the C# community Discord server for all the great stuff you guys do and talk about. Have a great day or evening. Bye from Brooklyn.